Hello students, in this video we'll discuss percentiles of random variables. If we're given a random variable x, we define the 100 times p percentile of x as the value pi sub p, such that the probability that the random variable x does not exceed pi sub p is equal to p. Now, we can look at this definition and we can think of this analytically. This, of course, is equivalent to saying that the CDF of the random variable x at the value pi p is equal to p, or that pi p is the inverse of the CDF evaluated at p, because the inverse of the CDF exists as it is an increasing, non-decreasing function. Good. Now, we can think of this geometrically as well. So if here's the x-axis and here's the PDF axis, f of x. If we have a PDF, and I want to find the 100p percentile of x, if I wish to find the 75th percentile, what I'll need to do is I'll need to find the value over here. I might want to find the 75th percentile, for example. And what that would mean is that would mean the area under the PDF up to that point will be exactly 0.75. I can have another situation like this. Here's the x-axis, here's the PDF axis. I could have a PDF that looks like this. And I could find something along these lines over here. Maybe I want to find the 25th percentile. And if I did that, that would mean the area to the left of that value, pi sub 25, would be equal to 0.25. And now we can see further along, if this was, for example, the value pi of 0.6, that would say that up until that point, the area, the total area under the PDF up until that point would be 0.6 up to that point. So that's geometrically what this percentile does. And so now we want to see some examples of computing these percentiles. And so but before we do that, we'll make one particular case. In the case when p is equal to 1/2 or 0.5, we say that pi sub 0.5 is the median of the random variable x. That's the median value, the way that's halfway in between. So now let's see an example. Let's suppose that x is an exponential random variable with parameter theta. That implies its PDF is equal to 1 over theta e to the negative x over theta. And then its CDF will be equal to 1 minus e to the negative x over theta. So that's our CDF. And so if we wish to find the median, so the question becomes now, what is the median of this exponential random variable? Well, the equation we have to solve is we have to look at the CDF and set the CDF equal to the median corresponds to the value of p being 0.5. So then what we have over here is we'll have 1 minus e to the negative x over theta is equal to 0.5, which says that e to the negative x over theta is equal to 0.5. Taking the log of both sides, we see that negative x over theta is the natural log of 0.5. And so therefore, we can find out that x, the median, the solution of this will be negative theta times the natural log of 0.5. And so that tells us for this that the median, pi sub 0.5, is this value of x. And this value of x is negative theta, the natural log of 0.5. Now, oftentimes, just as a remark, finding fx inverse of x, the inverse of the CDF, is analytically difficult. So in most cases, we won't be able to explicitly find an analytic formula or a closed form formula for the inverse of the CDF of a random variable, but we know that abstractly these medians exist, and so we can either approximate them graphically or we can approximate them from a table of data on what the distribution is. Thank you very much.